Now, another dimension to link selection is when you're in balanced mode, or load balance mode, you have three different options. There's a capacity option and a utilization option. And then there's a variant to utilization, which is new, which we just added, in which we include it's tunnel utilization as opposed to local label physical interface link utilization. So by default, and in the past, historically, when we're talking about load balancing, like high throughput and high efficiency modes, we use the local link, its current utilization, not the tunnels that you were sending on, but the INET A, what is its overall utilization? That's what we mean by local. So HE mode used link capacity, and the idea there is you fill the links proportionally to the total capacity. If you had 150 meg and a 50 meg like you see here, it starts out by filling the two links randomly, just loading them up proportionally to the size of the link. So it's basically trying to keep the utilization, the percentage utilized on both links at the same number. So they're both at 50%, for instance. And that's what HE mode does, high efficiency. And at first glance, you might think, well, that makes the most sense. That's the way you should do it, right? Not necessarily. That's the way people want to test it in the lab, because they want to do, they're like, well, I set it to high throughput, I'm load balancing, and I send 5 meg, then I expect to see 5 meg on this link, or 2.5 meg on this link, and 2.5 meg on this link. It doesn't, that's okay. That's what high efficiency and link capacity mode does. But that's not necessarily the best way to do it, because when you do that, when you load up both links simultaneously like that, it increases jitter significantly, because even if you don't have that much traffic, even with the small amount of traffic, you're putting every other packet on a different link, and the two links probably have different latencies. So in practice, per packet load balancing doesn't work very well, especially with unlike link types. I introduced this thing called link utilization, and in that case, the best way to think about it is that we fill the most open link first. So whichever link has the largest amount of overall bandwidth available, that's where the packet goes. The reason why that's important, the reason why I think that's actually a good thing, is because it keeps all the packets on one of the links until it needs to waterfall, until it needs to start load balancing. So you don't want to just load balance just for the heck of it, just because you think it's groovy. You load balance because you have to, not because you want to. The best thing you can do for traffic is keep the traffic on the same path, keep the latency and the path characteristics as consistent as possible across the duration of the flow, and it increases throughput. If you're throwing one packet that way at 50 milliseconds, and the next packet that way at 80 milliseconds, and this one at 50 and 80 and 50, you can imagine what that does to TCP and everything for that matter. You can now specify a link utilization mode where you prefer the most open tunnel. So as opposed to looking at the most open local physical interface like INET A or MPLS, we're looking at the most open tunnel. So we're taking into account, in other words, we're negotiating the tunnel speed. We say, all right, my end is 100 meg and your end is 50, therefore this is a 50 meg tunnel. It's not 100, it's actually only 50 because you only have 50. And it does that with all the tunnels that you connect to. And then when you set this guy here to balanced, and you set link utilization local and remote, it's going to fill up the tunnels to the other end, whichever one has the most bandwidth. So I personally think, just as a recommendation, I think that local and remote is probably the go-to option. Like if you had to pick one, it seems like you would want to base it on the tunnel. So I think that's a new feature that is probably the best one for most situations.